Yeah, so we covered quite a bit of territory as far as different topics, subjects. So I just thought I picked a couple of these problems from our past things we covered, starting with set theory. So on the handout there, number one, we'll start with sets. So U, the universal set, is 1 through 12. Set A is 4, 6, 7, and 8. And B is 3, 4, 5, 7, 9, and 10. All right, so see if we remember a few of these things. All right, so find the set A, and then that, and then B with that. Remember what that is? So that's A, what's that symbol? Intersect, and this B with the little apostrophe thing. What's that mean? B, complement?
Yeah.
Oh, the complement. All right, so what does that mean? Well, intersection, what was intersection? Where they have in common, what they have in common. And then B complement, what does that mean? What's not in B? And usually, if we have a complement, I like to write it down. So let's do that first. B complement. So that's where the universal set comes in. Universal set is just what everything we're considering at this time. And so this is B. And so what's not in B from the universal set? Well, universal set goes 1 through 12. So B doesn't have. So what's not in B would be 1, 2, 6, 8, 11, 12. With me there? All right. So we take A and intersect it with B complement. And so like we said, that just means what they have in common. And so what they have in common here, they've got 6 in common, right? And then 8, 6 and 8. Is it okay? All right. And then also part A is a union. Oh, U for union, right? What does union mean? Yeah, everything in both sets put together. So we take everything in A, combine with everything in B, and if we write them in order, so everything here with everything here. So 1, 2, 4, 6, 7, 8, 11, 12. So just everything of those two dumped together. Sound right? Okay. B. B, we have B minus A, whereas I like to refer to it as B take away A. So yeah, it is a subtraction sort of thing, but here's the way you do it. Here's the way I recommend doing it. This just says start with B and then take away anything that's in A. So I like to write, just start with this set. So B is 3. So we're back to B now. 3, 4, 5, 7, 9, and 10. And then you take away A. So take away anything that's in A. So I take out the 4. 7's in A. And that's it, isn't it? The rest of them aren't in A, so that's what this set is. It's 3, 5, 9, and 10. B take away A. So if it was A take away B, you do the exact opposite of that. You start with A and then take away anything that's in B. Okay? Remember that one? All right. C, so yeah, a few formulas to remember. Try to anyway. Fairly simple one for C. The number of subsets. What's the formula? Okay, remember? It's the power of something. Power of 2, yeah. I mean, if we write it sort of in a formula sort of thing, it's 2 to the n, and what do you suppose n is? The number of things there are, the number of elements, right? So the number of subsets of B is 2 raised to the number of elements B has. So 1, 2, 3, 4, 5, 6, yeah. B has 6 elements, so the number of subsets of B would be 2 to the 6th, which punch it in on your calculator are 2 6 times. 2 times 2 times 2. What is it? 64? Remember that vaguely? Sort of. So yeah, that's probably one you want to remember right there.
So it's 2 to how many numbers that's in the group of B?
Yep. So if I said subsets of A, it'd be 2 to the 4. Yeah, which is just 16. So there's 16 subsets, and remember, this also I think may come up on the little final there, but those subsets are made up of different sizes, right? Like one of the subsets would be just the subset with 3, and then the subset of 4, just one element each time. And then we'd also have subsets that are 2, 3, 4, 3, 5, 3, 7, you know what I'm saying? And so you've got the wide range of sizes of subsets, but if you wrote them all out, there'd be 64 of them. All right. What else we got? D. True or false? Yeah, so there might be a couple of true and false on the final there, but one of the main reasons for bringing this one up is remembering the notations here, the symbols. We have a couple of symbols. Remember what this one was? Well, it's not subset. Subset is this. Proper subset, yeah. And so remember, a subset is just, part of that set. I guess this set. We're talking about A. So 6, 8 is a proper subset of A. Is that true or false? Well, 6, 8, it is a subset. What does it mean, proper subset? Proper subset means it's smaller. Because one of the subsets of A is the set itself. But a proper subset has to be smaller. 6, 8 is a smaller subset of that, isn't it? So true. So remember the little symbols there. One other symbol I don't have on here that I'm thinking of. Remember what this was? A little funny looking E there. Element of. So go back and review those symbols. All right, then, I might have a Venn diagram to contend with on this. Draw a Venn diagram for this set. Well, remember, the Venn diagram was just a rectangle with circles. In this case, we got A and B circles. And remember, the universal set is the whole rectangle. And in this case, it wants us to put the elements in the appropriate spot there. So if we start at 1, well, 1 is not in A or B, so where does it go? Yeah, go on the outside. 2, same thing, it's not in A or B. 3, well, 3 is in B, but it's not in A, so where would it go?
B.
It goes in the moon shape here, B, right? Because B is this whole circle, so I can't put it anywhere in B. It has to go out here, in the moon shape, I call it. 4 is in both A and B. Where would it go?
Middle.
In the middle. Let's roll through these. 5 is like 3. 6 is in A only. B is in the middle. 8 is in A only. 9 and 10 looks like those are in B only. And then that leaves 11 and 12 on the outside. So that's one thing we can do with the Venn diagrams there. Good on that? All right, then F. Yeah, one other thing I focused on is the number of elements in A and B. First part. Yeah, so remembering what the word and the other one is or stands for is important here. What does and stand for? Remember? And was the intersection. And means intersection. What they have in common. So how many elements do these have in common? In the middle, right? There's two of them in common. We're okay? So we get the two. All right, then the number in A or B, or means the union. So that would be everything, all the elements in both sets. And so that's everything in A combined with everything in B. So just count, in this case, count up the elements in A and B. So 1, 2, 3, 4, 5, 6, 7, 8 elements. Question? All right. Moving on to number 2. So that was sets. Number 2, we go to logic. And remember a few fine details there. One of the things we did in logic was inverse and contrapositive, converse as well, but I didn't have that one on here. So I've got a statement, if-then statement. If I study, then the test is easy.
Not true.
You don't think that's going to be true? Well, logic can be, statements can be true or false, so. Maybe I should put, if I study, the test is easier. There you go. Okay. So what I want to do on that is, yeah, let's write the inverse of that. What does the inverse do? So we had the converse and the inverse. Those were sort of related, but different. Inverse, what did it do? It negated both parts, okay? Inverse negates. So we just take this part and negate it. If I don't study, then the test is not easy. Remember, the converse is the one that flip-flops. Just flips them around, makes this the if part and this the then part. The contrapositive, what does it do?
Both.
It does both, flips and negates. So the if part, so I flip it, so this is the if part, but on the contrapositive I also negate it. So if the test is not easy, then what? I didn't study. Okay, question? So we'll probably have at least one of those. Now, a large part of what we did, yeah, was those truth tables. So remember how those work? On number 3, we got a truth table for that statement there. I'll write it up here in a second. But remember, on a truth table, what you do is you put P and Q over here, and then all the truth values, different ways those could work together. Like P could be true, and then Q could be true. What else? We could have true, and then Q false. Or then we could have false, and then true. One more, there's 4. False, false. Okay. Yeah, so for ones like these, true, 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 false, false, true, false, false. Or some order thereof. Then over here we put the statement, which is not P or Q, and not Q, I gave it away there. Yeah, this is or, this is and. Sort of looks like a capital A, so sort of easy to remember, the other one's or. Okay, so parentheses first. Oh, yeah, what I like to do is go ahead and write underneath each one, because the little squiggly P means negate P or negation of P. So whatever we've got for P, which is true, true, false, false, this means negate it, right? So I would do false, false, true, true. And then Q, that's just a copy of the Q column, which is true, false, true, false. And then this is the negation of Q, go ahead and do it. So it's just the opposite of the Q, so it'd be false, true, false, true. Okay? Now we do the parentheses first. So parentheses, we're going to OR those together. How does OR work?
Either one of them can be true versus false.
One of them's true, it's true, right? Or one of them's true, it's true. So false or true is true, false or false, neither one's true, so that's false. It's the only time it's false. True or true is true, true or false is true. Mark those ones out now. Because then we take that result and we AND it, right? This is AND. So I AND these two together. How does AND work? Both of them have to be true for AND to be true. So true and false is false. False and true is false. True and false is false. True and true, that's the only one that's true. So that, the rest of them are just kind of work to get there, but this one is the final answer. Yes? All right. Number 4 on logic. True table for another statement. Not P arrow Q, but everything else is the same. PQ, true, 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 false, false, true, false, false. We've got the negation of P, so let me go ahead and write it underneath. False, false, true, true. Q is just a copy of the Q, so true, false, true, false. Then we have the arrow. The arrow signifies what words? What would the words be for the arrow? That's the if-then, right? So it's the conditional statement, we called it. But how does it work as far as true and falses go? It's a tricky one. The only time arrow the only time it's false, there's one time it's false. Remember what it was?
False is
Flip flop that.
True.
True arrow false, yeah. T arrow false, T arrow F, that's false. So that's the only time it's false. Everything else is true. T arrow T is true, F arrow T is true, F arrow F is true. Okay, that's what I mean. So over here, what do we got? The order is F arrow T. All right, so it's T arrow F that's false. F arrow T is true. F arrow F, they're both false, but that's still true. The only time T arrow, the arrow is false is at T arrow F in that order. F arrow F is true. T-R-O-T,
True.
that's true. T-R-O-F, that one's a tricky. Any questions on that? All right. So number 5, I've got some negations of statements. The negation of some classes are hard. Most of the time, we can just add the word not to the statement and it negates it. This is not one of those times though. Yeah, what you have to remember is the negation of some is not, some are not. Some classes are not hard. That would not negate this. You remember what the negation of it is?
None.
It's just none, yeah. No classes are hard. So the negation of some is no, or none. Yeah, none is the better word. So be careful on that. Now, B, pretty nice one. I will study and I will pass. You got a true statement? Hopefully it's a true statement. But what's the negation of that? Okay, so this one's pretty nice in that, all right, so negate that, that is I will not study. Negate that one, I will not pass. But what's the other thing we do here? Yeah, and changes. Yeah, the negation and changes to or. And vice versa, or changes to and. Remember that? Okay? C. If I study, then I pass. Okay, so this is the tricky one on this one too. Another tricky one. All right, so remember this one. So let me write. If P, then Q. The negation is P and not Q. So an if then, you take out the if then altogether and you replace it with and. And then the other little tricky thing is, notice, do I negate P actually? P stays P. The only thing I negate here is Q. So I said it's a little tricky there. So P is I study, so it stays I study. If then changes to and, I do not pass. Change, negate that. So anyway, try to remember that. Okay. All right. Thanks for going to probability here. Any questions on these? Which okay? All right, so number 6, probability. What's the probability of getting exactly 2 tails when you flip 2 coins? All right, so probability, you do the successes over the total there are, right? Basically how we do it. All right, so on some of these it might be good to write out the sample space here. We're flipping 3 coins, and so we list out all the possibilities there. You got heads, 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 2 heads and a tail, but you could do that heads, heads, tails, heads, tails, heads, or heads, tails. Sorry, tails, heads, heads. Those are all 3 different ones. And then you can have 2 tails and 1 heads. So tails, tails, heads, tails, heads, tails, or heads, tails, tails. Or you could have, last but not least, all 3 tails. So remember, flipping coins that. So the successes here are 2 tails, exactly 2 tails. So there's 3 of them out of 8. Okay. 3 out of 8. Now I also have on that the odds in favor. And remember, odds, they're different. The odds in favor, what you do is you do, well, the way we said it was favorable to unfavorable. So you don't use the total on the odds. Okay, so the favorable, you got 3 with exactly 2 tails. How many are unfavorable? No?
5.
1, 2, 3, 4, 5. Yeah. All right? Try to keep that with the odds. Okay. I'm drawing a single card from a standard deck. Okay, so you remember 52 cards, 13 in each suit. What is the probability of drawing a face card? Let's call it face card FC, or a diamond? Well, you might want to use a little formula here. The OR formula is face card, probability of face card plus, OR means plus, the probability that it's diamond. But then you subtract the probability that it's both. In other words, both a face card and a diamond. All right, so face cards, that's the queen, king, and jack. Jack, queen, king of each suit. So there's 4 suits. There's 3 face cards in each suit, so that's 12 face cards out of 52 cards. Diamonds, that's one of the suits, so there's 13 in each suit, so there's 13 diamonds. And then how many are both face card and diamond? Well, you got the jack of diamonds, queen of diamonds, the king of diamonds. 3 are both. So we subtract 3 out of 52. So since they've all got common denominator 52, just add and subtract 25 minus 3, 22 out of 52. With me there? So that's 11 out of 56. Question?
Where'd you get the 3 out of 52 again?
All right, so that's the ones that are both face cards and diamonds.
Okay, that's
So
correct.
jack, queen, and king of diamonds. All right, then, number 8, we're drawing 2 cards without replacement. Probability that both are black. So that means, we put it kind of better words here, it'd be black on the first and black on the second. So it's an and probability, and remember and means multiply. So we do the probability that it's black on the first times the probability that it's black on the second. However, there's a little condition. Condition is on black and second given, a little sign right there, you don't have to necessarily write this, but the second one's conditional. In that you do the black on the second given that black on the first happened. So we'll talk about that with that. All right. So black on the first, black again. The diamonds and hearts are red. The spades and clubs are black. So there's 2 suits that are black. 26 are black out of 52. So the first one is 26 out of 52. The second one, though, what happens? Black on the second, but given that black on the first happened. Now we're doing this without replacement, so we drew a black on the first, It's off to the side.
So it'll be 25 out of 51.
25 out of 51, yes. And then you multiply those together. And if you just multiply them straight, 26 times 25, 650. 52 times 51, that's 2652. And then you can reduce that, as somebody got reduced. 1/2. I think it's gonna be, what, 25 over 102?
Yeah.
Somebody got that? All right. Question on probability.